Hello learners, welcome to my channel. So in this video, I will give you proof of this integral. The value of integral 0 to infinity e to the power minus h square x square dx is equal to under root pi upon 2h. This is a very useful integral, especially it's used in solving many questions based upon gamma function. So like we have done gamma half, the value of gamma half was root pi, right? In the proof of this in the proof of gamma half, in the end we arrived at one integral which was 0 to infinity e raised to power minus x square dx. We directly wrote the value of this integral equal to under root pi by 2, under root pi by 2. Okay, so such type of integral is very useful. It will be used in solving many questions based upon gamma function. So let's prove it. So my integral is 0 to infinity e raised to power minus h square x square dx. I can write this integral as 0 to infinity e raised to power minus h square y square. Instead of x, I have just changed the variable. Instead of x, I have put y. Now, if I multiply equation 1 and 2, I get I square equal to 0 to infinity, 0 to infinity, double integral will come, e raised to power minus h square, x square plus y square, dx, dy. When base is same, powers are added. Okay. Now, we will convert this double integral into polar form. Now, understand this thing very carefully. The value of x is varying from 0 to infinity. So, x if we see in Cartesian coordinates, so x is varying from 0 to infinity, up to infinity, and y is also varying from 0 to infinity. Y is from 0 to infinity, means the first region, the first quadrant, this region is covering the first quadrant, the whole first quadrant. All this unbounded region is being covered under this integral. Okay, when we are converting it in polar form we have r and theta. Okay, theta is the angle, and r is the radius. So when we convert this region into polar form, the angle is changing from 0 to 90 degree. You can easily see here clearly the angle is changing, theta is changing from 0 to 90, and r is taking value from 0 to infinity. Okay, so the limits of r will be from 0 to infinity, and the limits of theta will be from 0 to pi by 2. Further, we know when we convert uh, Cartesian into polar coordinates, then x square plus y square is equal to r square. Okay, and theta is equal to tan inverse y by 2, tan inverse y by x, sorry, tan inverse y by x, and dx dy that will be changed to r dr d theta, r dr d theta. Okay, so these are the changes which we have to do here. So first thing, integral is of r. R is changing from 0 to infinity. Theta is changing from 0 to pi by 2. So this will be the limits. E raised to power minus h square, r square. X square plus y square will be changed to r square. Dx dy will be changed to r dr d theta. So these are the changes which we have done here. Now we have to solve this integral. This particular integral we have to solve. Okay, so what we will do, we will put r square equal to t. Now to solve this integral, I'll put r square equal to t. So let's put r square equal to t. So when you put r square equal to t, 2r dr is become equal to dt. So r dr become dt by 2. So we'll put here r dr to be dt by 2. We'll put r square here equal to t. and limits will remain same, because when r is 0, t is 0, and when r is infinity, t is infinity. So I square becomes 0 to pi by 2, 0 to infinity, e raised to power minus h square t dt by 2 d theta. Now we can integrate it with respect to t. We can integrate this integral with respect to t. So it will be, I have taken 1 by 2 outside. So e raised to power minus h square upon t upon minus h square. When we integrate e raised to power minus 80, the constant comes below. Okay, so uh, the constant is divided. Okay, now just put the limits. So 1 by 2, it will be, when you put infinity here, it will become 0, and when you put 0, it will become minus 1 upon h square. Minus will become plus 1 upon h square. Now the integral reduces to 1 upon 2 h square d theta, and it's 1 d theta. Integration of 1 d theta is theta. Integration of 1 d theta is is just theta, and limits are from 0 to pi by 2. So when you put the limits, you only get pi by 2. So when you only get pi by 2, you multiply pi by 2 with this, you get pi 4 upon h square. Now value of I will be under root of this. So I is under root pi upon 2h. Okay. So we get the value of this integral. So you can use it in questions which are based upon gamma function. It's a very useful integral, and you can use its value as it is. So in this way, we have done the proof of this integral. I hope you like this video. Please like, share and subscribe my channel, and feel free to ask your problems. Thank you so much. Have a good day. Take care. Bye bye.